Your media company needs to process videos uploaded by users and generate multiple resolutions, for 80p, 720p, 1080p, for playback. The system must be scalable and cost-effective. Options: A. Use EC2 instances with FFmpeg installed. B. Use AWS Lambda with FFmpeg. C. Use AWS Elastic Transcoder. D. Use AWS Elemental Media Convert. Correct answer: D. Use AWS Elemental Media Convert. Explanation: Media Convert is designed for video transcoding workflows and supports generating multiple resolutions. It's a fully managed service and scales automatically. Why not other options? Option A. EC2 instances require manual scaling and are costlier. Option B. Lambda isn't suitable for long-running video processing tasks due to its timeout limits. Option C. Elastic Transcoder is outdated and lacks advanced features compared to Media Convert. You are building an API for a web application that will handle millions of requests daily. The solution must scale automatically, be highly available, and minimize operational overhead. Options: A. Use an application load balancer, ALB, with auto-scaling EC2 instances. B. Use API gateway with AWS Lambda. C. Use a network load balancer, NLB, with EC2 instances. D. Use an ALB with ECS Fargate. Correct answer: B. Use API gateway with AWS Lambda. Explanation: API gateway with Lambda provides a serverless solution that scales automatically, requires no infrastructure management, and is cost-effective for high-traffic APIs. Why not other options? Option A. While this setup is scalable, it requires managing EC2 instances and incurs additional costs for auto-scaling and ALB. Option C. NLB is better suited for TCP/UDP traffic, not HTTP/HTTPS APIs. Option D. While ECS Fargate simplifies container management, it's still not as operationally lightweight or cost-efficient as Lambda for APIs. You manage an application that stores critical business data in Amazon S3. You must ensure disaster recovery across AWS regions with minimal data loss and low RTO, recovery time objective. Options: A. Enable S3 versioning. B. Enable S3 cross-region replication, CRR. C. Use S3 Glacier for disaster recovery. D. Use AWS Backup to create backups of the S3 bucket. Correct answer: B. Enable S3 cross-region replication, CRR. Explanation: CRR replicates objects to a bucket in another AWS region, ensuring that data is available even if the primary region is unavailable. Why not other options? Option A. Versioning provides protection against accidental deletions, but doesn't replicate data to another region. Option C. Glacier is for archiving, not real-time disaster recovery. Option D. AWS Backup doesn't currently support direct backups for S3. Your application requires a high-performance NoSQL database with predictable single-digit millisecond latency for both reads and writes. The database must also handle millions of requests per second. Options: A. Use DynamoDB with provisioned capacity. B. Use DynamoDB with on-demand capacity. C. Use RDS MySQL with read replicas. D. Use Amazon Elasticache for Redis. Correct answer: A. Use DynamoDB with provisioned capacity. Explanation: DynamoDB with provisioned capacity ensures consistent, high performance for predictable workloads and can handle millions of requests per second. Why not other options? Option B. On-demand capacity is better for unpredictable traffic but isn't as cost-effective for steady, high traffic. Option C. RDS MySQL isn't designed for NoSQL workloads or extremely high throughput. Option D. Elasticache is for caching, not for primary NoSQL data storage. Your company is migrating a legacy monolithic application to AWS. The application has a database tightly coupled with the application layer, and downtime must be minimized during migration. Options: A. Use the AWS Snowball family to transfer data. B. Use AWS Database Migration Service, DMS, for a live migration. C. Use RDS with multi-AZ deployment for the database and manually migrate the app. D. Use Amazon EC2 instances with Elastic Block Store, EBS, for both app and database. Correct answer, B. Use AWS Database Migration Service, DMS, for a live migration. Explanation: DMS allows live database migration with minimal downtime and supports heterogeneous and homogeneous migrations. Why not other options? Option A, Snowball is for offline data transfer, not live migrations. Option C, RDS with multi-AZ is for high availability but doesn't address live migration. Option D, EC2 with EBS is operationally intensive and not suitable for minimizing downtime during migration. You need to process massive amounts of log data daily, transform it, and generate insights using SQL queries. The solution must scale automatically and be cost-effective. Options: A. Use Amazon EMR with Apache Spark. B. Use AWS Glue with Athena. C. Use Amazon Redshift. D. Use Kinesis Data Analytics. Correct answer: B. Use AWS Glue with Athena. Explanation: Glue automates the ETL process, and Athena provides serverless SQL querying over data stored in S3, making this combination cost-effective for analytics workflows. Why not other options? Option A, EMR is scalable but requires infrastructure management and is more expensive for daily batch jobs. Option C, Redshift is designed for data warehousing but may incur unnecessary costs for large-scale batch processing. Option D, Kinesis Data Analytics is for real-time streaming, not batch analytics. You have an EC2 instance hosting an internal application. The application must be accessed securely by users from your corporate office over the internet. Options: A. Use a Bastion host for secure access. B. Configure an elastic load balancer with SSL termination. C. Use AWS Client VPN. D. Use S3 with signed URLs for access. Correct answer: C. Use AWS Client VPN. Explanation: Client VPN allows secure access to internal resources on AWS over the internet using a VPN connection. Why not other options? Option A, a Bastion host is for managing EC2 instances, not for accessing applications securely. Option B, an ELB provides load balancing, but it doesn't establish a secure VPN connection. Option D, signed URLs are for granting temporary access to S3 objects, not applications. Your financial services application needs to process transactions in real time and detect fraud using a machine learning model. Options: A. Use Kinesis data streams with Lambda for processing. B. Use AWS SageMaker for real-time processing. C. Use Kinesis Data Analytics with DynamoDB. D. Use SQS with Lambda and SageMaker. Correct answer: A. Use Kinesis data streams with Lambda for processing. Explanation: Kinesis data streams can ingest and process real-time transactions, and Lambda can invoke the ML model for fraud detection. Why not other options? Option B, SageMaker is for training and deploying models but doesn't handle real-time data ingestion. Option C, Kinesis Data Analytics is for SQL-based analytics, not running ML models. Option D, SQS isn't designed for high-throughput real-time data ingestion. A company generates 10 terabytes of log data daily that needs to be retained for compliance. The data must be archived in a cost-effective manner, with retrieval times under 10 minutes for regulatory audits. Options: A. Store the data in Amazon S3 Glacier Deep Archive. B. Store the data in Amazon S3 with intelligent tiering. C. Store the data in Amazon S3 Glacier Flexible Retrieval. D. Store the data in Amazon RDS with multi-AZ. Correct answer: C. Store the data in Amazon S3 Glacier Flexible Retrieval. Explanation: S3 Glacier Flexible Retrieval provides low-cost storage for archival data while allowing retrieval in 1 to 5 minutes using expedited retrievals, meeting the 10-minute SLA. Why not other options? Option A, Glacier Deep Archive is the most cost-effective but has a retrieval time of 12 hours, unsuitable for the scenario. Option B, Intelligent tiering is more expensive than Glacier services and is not optimized for purely archival data. Option D. RDS is a database service and is significantly costlier for storing large volumes of log data. Your web application is read-heavy and serves millions of users globally. The content changes weekly, and the infrastructure must provide low latency to users worldwide. Options: A. Use S3 with CloudFront as the CDN. B. Deploy EC2 instances in multiple regions with an application load balancer. C. Use Amazon RDS with read replicas in multiple regions. D. Use DynamoDB with global tables. Correct answer: A. Use S3 with CloudFront as the CDN. Explanation: S3 with CloudFront enables global content delivery with low latency. Weekly updates to content can be handled efficiently by invalidating CloudFront cache where necessary. Why not other options? Option B. Deploying EC2 instances in multiple regions is operationally complex and more expensive. Option C. RDS read replicas are better suited for database workloads, not static content delivery. Option D. DynamoDB is for NoSQL databases, not static content like web assets.